Okay, we're rolling, eh? Okay. Hey guys, Bert here, Sunova Surfboards. Today we're going to be talking about the technology in Sunova Surfboards and some of the features that are unique to our construction and why they give better and unique performance characteristics. Right, so the absolute first thing, I think it's probably one of the things that Bert and Sunova got a little bit of recognition for, and that is basically the parabolic rail, right? And so initially when I first came up with the idea, I just called them rail stringers or wooden rail stringers back in the day. I mean, not a very catchy name. And then I think it might have been early 2000s, I met a guy called Greg Law, and he used the phrase parabolic rail, and since then it just stuck. But the reality is it's probably not the right description, but it sounds cool. So anyway, what it is basically we've taken the stringer, right? So normally in a normal surfboard you have a piece of foam, right, whole board, and then you'll have a bit of wood that runs down the middle. Okay, but in a Sunova, the foam is bare, there's no stringer in the middle, and the stringer is basically running around the outline of the board, all right? So what happens is, if you ride a board that does not have a stringer, let's say it's an old PU, you get an old PU longboard from maybe back in the 50s, early 60s, before they were using stringers, and it's very floppy, right? You paddle the board, it's got this ugly reverb, you surf it and you can feel this soft flex going through the board, right? So what a stringer does in a normal board is it helps the board return back to shape quickly. So once the board's been flexed, the stringer helps it spring back quicker, because without the wood, the spring back is a bit slow and sloppy and floppy, and just the board's not positive, right? So that's what the stringer does in a conventional board. But if you think about it, right, what happens is the stringer will be the stiffest part of the board, and the rails, they're just foam and fiberglass, so they can actually flex slightly different to the center line of a board. Right, but we've established that the wood running down the middle of a board, it's the magic bit that you kind of need to make the board feel positive and to spring back into shape quickly. Right, so our boards, most of the spring back comes from the rail line, right? So if you can imagine, you're on a normal board with a stringer, you got it on rail, half the board's in the water, right? Foam and fiberglass. Your stringer is in the middle of the board, but that's up out of the water. Now, as the board flexes, the stringer wants to spring back, right? But it's out of the water. Whereas in our case, the spring back is coming from the rail line, okay? And that's down deep in the water. So you really get a feeling of when the board flexes, as it unloads, you get so much more spring, because on a normal surfboard, you're only just relying on foam and fiberglass in the rail, but that's where you actually want the spring back. So what we've done is the spring back that normally comes from the middle of the board, we put in the rails, gives it a totally unique feeling. A lot of people would use the word slingshot or catapult, drive, projection. So what ends up happening is, as you put it through a turn, you can just feel the thing wants to keep its speed, and if you flex it up a bit more, it just wants to spring you out. So that's the parabolic rail and the stringer that runs the rail line, and that's the feeling that it'll give you. So the next one that's unique to our construction is our decks. So if you have a close look, you see like these little black lines, okay? And so on the deck we also run a thicker deck skin, and that's just to give the board a bit more like toughness and stiffness on the deck. And then we also have underneath the wood, there's a layer of glass that sits on the foam. Then these little I-beams run through, and they connect the glass under the wood to the glass over the wood through the wood. And what it does is it just gives the whole deck so much more structure, because the surfer, he needs to transfer his energy from his body, through his feet, through the deck to the board, right? And so it's very important that the deck is kind of stiffer so that your load transfers across the entire board. So the stiffer deck skin and the I-beams, just to make it a lot tougher and sort of hold it all together. Okay. The next one is the bottom flex, or the bottom skin. So we have a certain amount of wood in the rail for the spring back. Obviously we've got the deck, transfer the rider's energy. The bottom, complete opposite, right? On the bottom we have a thinner bottom skin, lighter, lower density wood. And the goal is, when you press the bottom, you want it to squish in a bit, and you can actually feel that. You come up to one of our boards, you go to dent it, it doesn't actually dent. It just presses in like marshmallow, springs back. So what that does is, as you hit chop, if you have a board that's really stiff, and there's a classic example, I'm going to use carbon fibre. Carbon fibre transfers energy really well, all right? And as a general rule, you can feel every little bump through carbon, and it transfers through the board back to the rider. And so if you're surfing along and there's little bumps and chatters on the face, your board's just going to be going bounce, 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 flutter, flutter, flutter. And a lot of people complain that when they ride light boards, right, if they're too rigid, they just bounce around on top of the water. So while our boards are light, it has this soft, flexible bottom skin, and so as you're riding along, the bottom literally just absorbs the chops. And I think probably one of the best examples of it is watching Sebastian Stoitner on like 80-foot waves, just screaming across, and everyone else is just getting bounced off by these giant like bumps and lumps. And you can just see his board just super smooth, just cutting through the water. So that bottom skin is very important to have it so that it's soft and flexible, and it gives you a cushioned ride. So part of that is also the core that we use, right? So we use an EPS core, and what that does, EPS comes in a range of densities. So EPS comes in a range of densities anywhere from 8 kilo a cubic metre through to 40 kilo a cubic metre, right? And so obviously the heavier the foam, it's stiffer and harder, and the lighter the foam, it's lighter, more flexy, more marshmallow. So we use the lightest EPS we can get, around about 13 kilo a metre, cubic metre. We will go a little bit lighter for bigger boards, but for surfboards, it's a durability thing. And so we want to have a super lightweight EPS core. Now the beauty with having it super light is that makes it a lot more flexible and a lot more marshmallowy. But then on top of that, it means that we need to run a vent, okay? So when the core material is a lot softer and more kind of squishy, what it does is it allows the board to flex more, because as a board flexes, literally, if you get a book and bend it, shame I don't have a phone book, old school, I don't think anyone, does anyone own a phone book anymore? If you get a book and bend it, and as you bend it, you watch all the pages slide past one another. And if you bend it the other way, right, and so on. So basically, whenever something flexes, you have to have shear motion, right? Where the top and the bottom can literally slide past one another. Now, if you run a very stiff core material, you don't get that shear motion. Whereas if you have a very lightweight, flexible EPS core, as the board flexes, the top and bottom can slide past one another. Now, part of the deal there, I mentioned the vent, okay, so I'll go to that next. The vent needs to be there because what happens is the super lightweight EPS core, it's like if you were to fill up a box full of ping pong balls, And then if you can imagine, there's a space between all the balls, and that's kind of what EPS looks like under the microscope. It's like lots of little ping pong balls, and they're like a sealed unit. And it's almost like they're spongy ping pong balls, because you can get an individual bead, you can squeeze it, and it just pops back. And so when you have this full EPS core, super lightweight springy beads, plus there's a space between the beads, that space contains free air, and that air needs to escape. Okay, so what ends up happening is, it's possible you can build a board without a vent, but to do that, one, you've either got to use a way higher density core, or two, you can actually allow a little bit of resin to soak into the foam a bit. But what ends up happening is that again stiffens the board up, because you can actually have a matrix of resin that goes around the beads and through the core and actually joins the top and bottom together. And then you come back to that same old issue. When you connect the top and bottom, they can't slide past one another, and you kill the flex. So we really use the super light EPS so that the board flexes really nicely, and then any issues with excess air buildup or pressure is completely taken away by the vent. And so the Gore-Tex, it's a self-breathing membrane. And so what happens there is air can go in as the board cools down and it wants to draw air in. It'll just suck air in. As it heats up, it'll let the air go out. So it'll allow air to pass in and out of the board, but the membrane is so fine that it does not allow water to pass through. So that's set, forget, you never have to touch it. And what that means is the board can breathe, always stays equalised, I guess. And it's part of the deal. So if someone's trying to sell you an EPS board without a vent, right, you're going to have one of a few issues. One, it's not going to perform as good because they've either resin impregnated the core and that stiffened the whole board up, or two, you're going to have blister or bubble or delam issues. So a vent is super important, and you can go back all the way to the old windsurfer days, and virtually every big windsurfer and board with an EPS core had a vent. They were manual back then. Some people still use manual. Ours is completely automatic. You never have to worry about it. High density foam inserts is the next thing on the list. So we have our lightweight EPS core for performance, but of course the EPS actually has zero, I would say, constructional value, right? All it does is it just gives us a shape to vacuum form or to form a shell of wood around the core. But it literally doesn't have any like engineering value whatsoever. So when it comes to the inserts and the fin systems, I've just got a few samples here of high density foam. So what we do here, if you can imagine, so this is pre-machined, and it's all perfect and precision, so that a fin box just fits perfectly into it. Or in this case, the FCS plug, it's like zero, like 0.1 of a millimetre tolerance. And so what happens is this stuff will be put inside the board into the EPS foam. And what it means is, because one of the biggest problems with existing fin systems is it's not the fin system itself. You'll find that they're very adequate, they're more than strong enough, but it's the foam and the weakness of the core material that boards are made from that fail. And so by creating these high density inserts installed into the inserts, and it's more than strong enough, and it really helps just spread the load. And this stuff's super, super hard as well. Now in this case here, I have a board with the old FCS. We do a range of fin systems, and I would like to talk about the Flex and FCS in general. So what happens is, you'll find it's going to have a straight bit, a kink, and a straight bit. And really when Future's fin systems break, you'll always find they break between the fins here or in front of the fins here, because the board wants to flex, and in the process of flexing, a certain amount of load is absorbed. And when you have stiff spots in your board, it literally just transfers the energy to the next spot where it can flex or kink a bit. So So that's Futures versus FCS1. So FCS1 in our boards just has a really nice, clean, even flex through the tail, and you can really just load the tail harder into the pocket, and you just get a lot more spring back out of the lip. But the reason we can use FCS1 with absolute no problem is because we set them into these high density foam inserts which go into the board, actually come through to the deck, and then we also we make up these bamboo plates, and it's basically real thin sheets of bamboo, and we make up like a plywood. We actually put glass in between as well, and we build that up with multiple layers, and so we call that an impact plate. And so quite common with an FCS is if you give it a good knock, maybe the back of the fin wants to punch into the board, or the front of the fin wants to punch in. This impact plate is so hard to cut through because it's just multiple layers of fiberglass and like a bamboo ply. So that covers our high density foam inserts and our fin plates. So I'll just get rid of that. Now the other thing too, so in general, when you're running an EPS core, people, if the board gets damaged, it's pretty easy for water to get in, right? So one of the reasons we use the super light EPS is it's so light that if I was to have a block of it here, and we'll probably get to do this experiment one day, if I had a block of foam here and I poured water on it, within a couple of minutes the water would just go right through and drip out the other side. So a super lightweight EPS, water can get in, but water can get out really easy. Now in our boards, every little knock and bump and ding, really way less stress, because you've got your core, then we have a layer of fiberglass and resin, then we have the wooden skin, and then we have another layer of fiberglass and resin. So you've already got that top and bottom, and then when it comes to the rails, you know, you've got 12 millimeters of wood here, plus you have your nose and tail blocks, which are solid balsa. And what ends up happening there is it can be knocked, it can be open, it can literally be raw wood. You can have cracks in your rails, you can even have some little splits, maybe you see a little stain. Water just doesn't want to get in, you know, you've literally got a double glass job on these boards. So a lot more durable. And with the nose and tail blocks, yes, it gives you that nice aesthetic look, but really, noses and tails, they cop a beating all the time, and so it really is just a practical thing. And probably one of the last things I wanted to talk about is the colour of our boards. And the fact that they stay in pristine condition for so long. Excuse me. So what we use is an automotive finish coat here. It's normally referred to as a 2-pack, and what it is, it's almost like a resin. And it's 2 parts, you mix it together and it will go hard, and it has some amazingly good UV qualities. So companies like Ferrari, Rolls-Royce, Bentley, they will actually go and put the time and effort in to finishing their cars with 2-pack clear. And what it does is it just gives you a good, hard, strong finish, a really good seal. But the best thing with 2-pack is it has amazing UV stability, and it has amazing UV qualities. And so when you spray a coat of 2-pack clear on, everything that's underneath, it just protects it, and it stays clean and keeps its colour and stays in great condition forever. If you don't use 2-pack, you'll find that most epoxy boards, I mean, they start going yellow on the shelf. I mean, I see other brands and I've got like brown spots and patches on them because they've been exposed to the sun, and they're brand new. They haven't even been pulled off the shop shelf yet. So it turns out without a 2-pack finish, epoxy in general just yellows off and browns off quite quickly. So that's a little bit of the rundown on the tech. I explained a little bit about the FCS. Now we do also have, we'll pull some others out. Of course, so we will do all the fin systems here, okay? And in this case, we have futures. Now, I have my preferences. I'm sorry about that. But look, I think that's for competitive guys. So when I say if you're a really good surfer, like maybe a pro or an ex-pro, I mean, look, I even know myself, I can still feel it, right? But for a lot of guys, no, it's not that important. And a lot of crew, they like their futures. Futures has a good reputation as being a solid fin system. In our boards, even more solid because it actually sits in that insert there, okay? And then we also have the, I'm sure I saw another one. Oh, we did have FCS too. Okay, sorry, blew it, guys. I was just gonna, so okay, we do all the fin systems, totally no stress, all good. While I'm here, just want to talk about this blue line, okay? So this is the construction we call more flex, okay? So what happens is you have basically 1/2 inch of wood or 12 millimeters of wood in the rail, and we've replaced probably 30 or 40% of the rail wood with foam. So what that does is that allows the rail to flex a little easier, a little softer, kind of under less load. So as a general rule, the Moreflex works a lot better in small soft waves where you're just relying on the power of your own legs squatting and extending to flex the board. And so you want the board to flex under lighter loads and give you sort of a spring back feeling, right? Now when you have more wood in the rail, it takes more effort to bend it. But then when it unloads, it just springs back with so much more force, so much more projection, and that catapult feeling. So lighter guys, smaller waves, Moreflex works really well. When you get into bigger surf, yeah, you actually want that little bit more wood in the rail. It's almost like running a thicker stringer. Instead of a 3/16 stringer, you're running a 1/4 inch stringer. That would be, I suppose, how you compare it to a normal board. It's just like running a bit more stringer material, and that stiffens the board up, gives it a bit more of a positive feel when you're in sort of slightly thicker surf. So, gave you the rundown as far as the rail, parabolic rail, what that does, what the deck skin does, how it transfers the load nice and stiff, what the bottom skin does as far as the flexible bottom, gives you the smooth cushioned ride, the EPS core, why we use it, because it can breathe, and it's very flexible. But because it breathes, we have the EPS vent that lets the air out. The high density foam inserts, we had our fin plates, nose and tail blocks, and of course we have this nice 2-pack finish. So that's sort of the range or the roundup of the features. And then what I wanted to discuss next was we have another construction over here. And essentially, I'm going to say the same thing, right? Everything about this board, what we've done is we've just swapped out the balsa for a Polonia. The Polonia is a slightly different density. It's a little harder, it's a little heavier. So we've had to make it a little thinner to compensate, but the balance is really nice. And so these boards equally feel as good. And so just been working with some team riders recently, and we've been doing some variations of constructions, and honestly this one is coming up really good. It's liked. So this particular one, we have the Polonia top and bottom, and instead of the wooden parabolic rail, we're basically using carbon fibre. Now, the carbon, there's not actually as much of it in comparison to the wood, but then carbon also is very stiff too, so it'll still bend and it'll spring back. I mean, if you look at these guys that do the pole vaulting, right, and you see like they use these carbon fibre poles, and dude, I can't believe those things don't snap. But the thing is, they do bend and really spring back. So carbon will bend and it'll spring back. But it does have a very fast rate of spring back. And I have honestly felt when I've had full carbon boards in the past, I've almost felt like an oversensitivity. Whereas just with a bit of carbon in the rails, it's just enough to help the board flex and spring back and give it a positive feel. So other than that, this is just another look. But essentially everything I've said about our construction, these boards pretty much well perform in exactly the same way, and they just have a bit of a different look, slightly different feel. I personally feel they feel a little bit better when the waves get a bit punchier, not quite as lively, a bit more of a toned down feel. Feels like you can just sort of lay into them a bit harder, and yeah, I don't know, it's kind of like slightly toned down response time. And when I say slightly toned down, I mean like a nanosecond in comparison. All right, guys, I think that's about it. I sort of, don't know, started waffling a bit. I lost my place. So, yeah, look, I mean, just spent a good amount of time there explaining the various features. So I'm not sure if that's going to be one vid. I'm pretty sure we'll probably break that down into 9 or 10 small little vids, and maybe there's one full one as well. Yeah, look, that's a little bit of info about our construction. There's actually more, but for now, I'm signing off. Bert Berger, Sunova Surfboards, Dr. Feelgood's Design Wrap. We're back. Catch you guys.